Okay, so in this question, we have a piece of pipe with a radius of 2 centimeters, and we're told that the end effects are 0.60 r. So for us, that's 0.60 times 2 centimeters, so that's equal to 1.2 centimeters. And we're told that the speed of sound in air, in this case, is 343 meters per second. Remember, this can be different in different questions because it depends on the temperature of the air. Now, in part A, we're asked about a pipe that is closed at one end, and we have a frequency of 600 hertz, and we need to work out, well, what length do we need in order to get the fundamental. So let's sketch a little diagram showing what that would look like. Here's our pipe. We do need to account for end effects. So the antinode is actually a little bit outside the end of the pipe. So this length here is, because it's closed, this is quarter of a wavelength. And that consists of the length of the pipe here, L, and then the end effects on the ends here. So we can write L plus E is equal to lambda over 4, and what we're asked to find is L. So we need L, which is equal to lambda over 4 minus E. Now we've worked out what E is up here, so now we need to work out what lambda over 4 is. To work out lambda, we can use V is equal to F lambda, rearrange it, and we end up with, lambda is equal to V on F. V is equal to 343 meters per second, and F we were told was 600 hertz. So that gives us 0.57167 meters. Our end effects are in centimeters, so let's just do everything in centimeters. So this is 57.167 centimeters. We just times it by 100 to get centimeters. Okay, so now we can substitute in here. So L is equal to 57.167 on 4 minus E, which is 1.2. And solving that one on the calculator, we end up with 13.09 centimeters. But everything, well, this end effects was given to 2 significant figures, so we should answer to 2 significant figures. The velocity was given to 3 significant figures, but we answer with the piece of data we used with the least number of significant figures. With the frequency, that could be 1, 2, or 3 significant figures, so we'll just go with 2. Okay, part B then says what length will give the fundamental if both ends are open. Okay, so with both ends open and accounting for end effects, we have the antinodes just outside the ends of the pipe at both ends. So we've got end effects at that end effects at that end. This is the length of the pipe. And in this case, with 2 open ends, for the fundamental, we have half a wavelength, 2/4 wavelengths inside that pipe. So here we have lambda over 2 is equal to 2E plus L. And we need to work out what L is. So L is equal to lambda over 2 minus 2E. And we have worked out what all these things were before. We're not changing the frequency or the velocity, so the wavelength doesn't change. So this is 57.167 on 2 minus 2 times 1.2. Solving that on the calculator, we end up with 26.18 centimeters. So to 2 significant figures, this is 26 centimeters. And that's how we solve that problem.